In this video, we are going to obtain the general solution of a differential equation x squared dy by dx is equal to x squared minus xy plus y squared. Now, what do we do? If you look at it keenly and do a simple analysis, you realize that this is a homogeneous differential equation. So after knowing that, we realize that the next thing is to divide through with x with the highest power. So we come and say this will be x squared out of x squared dy by dx is equal to x squared out of x squared minus xy out of x squared plus y squared out of x squared. Yeah, so simplifying this, we end up having this cancels with that. So we have dy by dx is equal to 1 minus y out of x, and then plus this one can be y out of x, everything squared. But for homogeneous differential equation, we always let y equal to u x. So therefore our u is the same as y out of x. So we also go ahead to differentiate y. So we shall have dy by dx is equal to u into 1 plus x du dx. So we use product rule there. So we simplify that. So in simplifying that, we shall have our dy by dx is equal to u plus x du dx. Now we are going to substitute it here. So we are going to substitute it there. So on substituting it there, we shall have our u plus x du dx is equal to 1 minus u plus u square. Yeah, so we have it as that. So collecting like terms, this u goes this side, so we end up having x du dx is equal to 1 minus 2u plus u square. So doing some rearrangement here, we can have it as x du dx is actually equal to u square minus 2u plus 1. Yeah, now if you analyze this, it can be factorized. So we can say that our u square minus 2u plus 1 is actually, doing factorization, is actually u minus 1 square. So we can put it back. Putting it back, we have x du dx is equal to u minus 1 everything squared. Now we collect like terms together. So on collecting like terms together, separating variables in simple terms. So we are doing separation of variables. So if we separate variables, So we shall have 1 out of u minus 1 square du is actually equal to 1 out of x dx. Yeah, so the next thing is to integrate. So we shall have the integral of 1 out of u minus 1 everything squared du is equal to the integral of 1 out of x dx. Simplify, and then when you integrate, we go slowly. We are going to integrate the left hand side. So for the left hand side, we can begin by saying let for example p equal to u minus 1. So we have dp du is equal to 1, which gives us dp equaling to du. So substituting it back, we know the right hand side is easy. Substituting it back, we shall have integral of 1 out of p square dp is actually ln is equal to ln x plus ln k. Going further, so to integrate this is the same as p power negative 2 dp is actually equal to ln of kx. So this eventually becomes negative p to power negative 1 is actually equal to ln of kx. So simplifying this is the same as 1 out of negative 1 out of p is equal to ln kx. So we put back a p. P was putting back a p, so we have negative 1 out of u minus 1 is equal to ln of kx. But now our u, so this is the same as negative 1 out of y out of x minus 1 is equivalent to ln of kx. Yeah, so ln of kx. Now simplifying the denominator, if we simplify the denominator, getting the LCM and so on, we shall have negative 1 out of y minus x out of x is equal to ln of kx. So which eventually left hand side becomes negative x out of y minus x is ln kx. Now cross multiplying and simplifying, so we can have negative x out of ln kx is equal to, so we have cross multiplied and divided. We have cross multiplied and divided, so it's equal to y minus x. So remember, our main aim is always to get y where it originated. So we can take this side. So when you take that side, we shall have negative x out of ln kx plus x will equal to y. So rewriting it very well, we shall have y is equal to x minus x out of ln kx. So you can just pull out the common factor in this case. So therefore our final y becomes x into 1 minus 1 out of ln kx. There you have simplified it. You can even go ahead to simplify it more, like you finish it and say my y was originally x out of ln kx into ln kx minus 1. Yeah, and then that is the general solution of the differential equation. Thank you for watching. Please subscribe if you haven't subscribed. Please subscribe. Yeah, please subscribe. Like the video, share it with your friends because sharing is caring. Thank you so much. Comment for any issue you have. We meet in the next. Thank you.